So how many people joined so far? 7 people. Only 7 people. Well, where is the chat? Yeah. Well, yeah, today I just wanted to give you an introduction to Lab 4 because this is like the most important lab that you must do. It's the most that's like the main, let's say, because lab 4, 5, and 6 they are based on this lab. But I was hoping that it would be more than 7 people that can join. Anyway, this is let's okay, now we have 8. Great, one more. Okay, anyway, so lab 4 we didn't publish this yet, but we will publish this soon. And yeah, I will just go through the if I can find the branch here for you guys. So yeah, now I have the README file that's in our secret repository here, but we are almost finished with working on this lab, and we will publish it for you in a few days maximum, so that you can get started. And so maybe all the text that you see here, it's not, it can still change, but I will just tell you now orally what this lab is about. So please just stop me if you have any questions. And also, if you want me to explain more about how you can implement this or do this, also please just ask and I will try to elaborate. But for this lab, you will be in the same group that you were in lab 3. And the main objective here is to implement the Paxos. And the way that you will do this is primarily to first implement the single Paxos, the type of Paxos that only decides one value, and then it terminates, it's done. And then to expand on this to allow for multi-Paxos so that you can reach consensus on multiple values. And then after you implemented this algorithm, you have to run this in a binary application. You have to create a binary application that you will run on at least 3 separate machines. So again, this can be either physical machines, for example, the Python machines, or it can be Docker containers, or it can be virtual machines. We will pretty much allow any constellation that you can imagine, as long as not everything is running on your local host. It needs to be some isolations between the participants. So, for example, there is one tool that's free, VirtualBox. You can download this tool and you can install Ubuntu, for example. It's very easy. Or this lab already has some description about Docker, and you know about the Python machines. So please don't come to the lab on the deadline day and say that you want to show your code or your solution, and you have it only running on localhost, because that's not sufficient. It needs to run on different machines. So yeah, I already shared these papers with you, slides, and we went through 2 of these slides together. And it can be valuable for you to go back to them and review some things with the protocol. So the lab starts off with some basic questions, and you know, some people will try to answer this first and then do the labs, but or you can just start coding and then you can answer this later. Any way that you choose, it's fine. Just it might be one suggestion is that you can first take a quick look on these questions and answer those that you can. But for example, the first question here, well, it's easy to realize this when you know the answer already, then it's obvious to you. But you might see this more clearly if you have tried to do the implementation. Then you will see what's an appropriate answer for these questions. So we have a nice figure here, I hope, or maybe it's not so far away. I will try to find it for you all. Yes, maybe we placed it in another place. Let's try to find it for you guys. So let's see here. Yes, so, oh, yeah, okay, anyway. I will make this a little bit bigger for you. So this is the, I just open. So now it's great. So this is the overview architecture of Lab 5 that, well, almost. And it can be useful to keep this in mind. Of course, we will share this. But here you see you have your FD and LD. This is the failure detector and the lead detector that you already implemented in Lab 3. Then we have the proposer, acceptor, and learner. These guys, this is the Paxos roles. And you don't hear me? One moment, people, one moment.
We don't have your voice.
You don't have my voice?
Yeah.
Yeah, make it. Okay, we have some problems with the audio. Hello, hello, can you hear me? Test, test. Ah, they're saying they can hear me. Maybe it's okay. We have maybe some problems. Wait, they said they can hear me.
Yeah.
They say that it's working.
But I can hear you. I don't know what's the problem.
You can, yeah, they said that's working fine. All right, we will continue. Some
It's fine for them.
minor technical difficulties there. Yeah, okay, so yeah, these brown or beige boxes, they are the Paxos rolls. And yes, what I wanted to say is that you will not put these three on different machines. Like all of the three, you can think of them like the three different parts of the algorithm, and they will all run on the same machine. And this machine, it will also run the leader detector and the failure detector. So don't think about this as like a lot of different machines for the different parts there. No, every participant will run everything. So yes. Yeah, so the failure detector, the lead detector, the proposer, the acceptor, the learner. Here we have supplied you with template code, and I will just show you what it looks like. You probably know already, but yeah, for example, if we go to the proposer, hopefully I will not bring out a solution here, so you never know about this. Well, now I didn't see anything, but it should be, yes, here, great. So this is how it looks like that. We will give you pretty much the structure of the code, so that you don't have to think about how to structure it so much, but we want that you take the description from the papers and presentation and try to translate it into the code, so that you need to tell the code here what is the algorithm supposed to do. For example, here he receives a promise message, and then he returns back with the accept message. Or it can be, yeah, in this case, here it's one. Yeah, the main idea is that you need to figure out what should be in this from field, the slot field, the round field, and then this Boolean here. So here you will implement it. And if you think about it, it's not so difficult if you just go to the resources that we posted. I'll try to find it here. Yeah, we'll just mute someone. Yeah, so I had these slides for you. Now I'm giving you some free tips here. Let's see if I find the correct slide that I'm thinking about. Maybe it's this, or maybe it's this one. this one. Yes, this is insanely simple. I already showed it, but I showed it to you. But if you go here to the last page, or it might be not exactly the last page, but in the end here, page 64, you have the pseudocode. And what's the great tip for you here is that you see here, proposer, when we get a promise message, all right? And you can go back to the code and you just see here, wherever I had the code here, that this is actually in the Go code where this pseudocode happens. So if you're able to sort of understand this pseudocode, and there's also some comments here next to the thing, then your main task will be to take this pseudocode here and just translate it to Go code. So if you're able to do that for the proposer and also the acceptor, because we have the same to do in the acceptor, then you are very close to be finished with the algorithm part. So that's one tip I have for you, to check the pseudocode here and try to understand what what happens here, and then write it into the Go code. After you think that you did this, you will run the tests, because we have some tests that you run in the normal way, the Go test. The description is here, but yeah, I guess you know all how to run a test. Okay, it's not. I thought it had some instruction how to run a Go test, but I guess you need to figure that out yourself, how to run a Go test. Anyway, then you will run the Go test, and it will, like here, you see, you run a Go test, and then we have coded in some tests that will tell you if the values for the promise and for the round, etc., if they are correct or not. So then you will keep adjusting your algorithm until these tests passed. And once you did that, the only thing remaining is the distributed implementation. And this is where most people have some issues. And there's no reason for this, because if you could already do the algorithm, this is very easy peasy for you. So what the main people, the idea that people or a lot of students, they can spend a lot of time to think about, how can I get started with this? How can I take this algorithm and run it? You know, because in the code here, you are only asked to let's close these things. Implement some algorithm. So like now, the first part is the fail detector, leader detector, proposer, acceptor, learner. Then what's the distributed implementation? It's the rest of the 4 boxes here, basically. So you need to think about this. And now here comes the what it means to be like a computer, what is it, scientist or engineer. or programmer or whatever the title is. But you need to think about the architecture of your thing, your solution. So here it's already giving you some tips here that we say that there is a client, okay, and then there's a server. And also in the text here, if you would scroll down to the end, to the test scenarios, you will see somewhere that we, I guess here, that you should start a cluster consisting of 3 Paxos nodes and start 2 clients. So this hopefully will tell you that we would have a client that's just a simple client that doesn't have any advanced algorithms or anything. It's the main job for the client is just to send a command to the Paxos servers and wait to get the consensus value back. And then we have 3 Paxos nodes that are running the Paxos algorithm, of course. So some students can make very elaborate and very great solutions for this, and that's great. But if you want to just complete the labs with the minimal effort and are just glad to finish, then you can just hard code these 3 nodes, the IPs or the ports of this. If you have, for example, on a Docker containers or virtual machines, it's very easy for you to just define the IPs of these different servers and what ports they will be running on. And we will allow you just to hard code these things if to save you some time, so that you can you can assume that you have 3 Paxos instances, and you know the IPs of them. And the same with the client. You can assume that you know the IPs of the Paxos server and what ports it's running on. If you want to code some discovery protocol or something like that, or configuration file or whatever you like, that's very cool. But just in order to pass the lab, we will allow you to hard code the IPs. Then if you're new to programming, you will maybe ask, well, how can I make an application in Go? Because we didn't see that too much. So I already said it for the leader lab 3, but the main thing is that you need a main function. So and how does a main function look like? It needs to be in package main. So I don't know if I have any example ready to show you. Well, I guess it doesn't matter because usually main functions can be very easy. So it can be so simple as this here, that we have just the main function, and it's package main. It has a function called main, and then it's importing some stuff and running a command. This is so in your example, you would run listen for Paxos commands or something like that. I will not tell you exactly what you should do, but yeah. So you need to have a main to build a binary, and you need to have two different main functions. One for the client that will be its own separate thing, and then for the server. The server implement or uses the Paxos implementation that you did, and the client, he doesn't know about Paxos. Okay, so the client, it's not very easy. He just need to talk with the server using HTTP or TCP or UTP or what's the other thing we protobuf. Yeah, pretty much the main thing is that you can have some network communication. And that's the main idea for that. Then once you're able to do this, there's just one thing left that it's a difficulty for students, and that's the benchmarking thing. And don't be afraid to ask the TAs for help for this, or me or anyone, because this can be a bit tricky for you to do if your implementation is not the best, because actually you can make the algorithm work, and you can make the distributed application work, but when you get to the benchmarking step, you can have some issues. And the reason for this is typically that here we tell or we say that you need to issue 500 commands very fast. And if you have some deadlocks in your code, like there is some race conditions, then this benchmarking will stop halfway, or yeah, at any point it will stop, and it will never give you an answer. And this is a very, very typical problem that students face, and it's kind of difficult to see. Sometimes it can be difficult to see why does it stop, when does this happen, and you can spend a lot of time on this. But one tip that I will just show you now. Of course, I don't have the greatest setup ready for you guys, but let's see. Let's try another. Let's try another one. So I wonder if I have one here. Yeah. Let's if I pull down this just for an example for you all. So, yeah, let's just do git clone here. So let's pray that it works. Let's do another one. Let's take Let's take another one. Huh? You can see if I have one here. And I just want to show you that there is one, one flag. It's called race that you can use for this. Let's see if it works. Yeah. So. Okay. So I think you can do something like this, and it will fail. But let's go to the lab 3, for example. So okay, so now this is what I wanted to show you. Okay, so now this is how you test everything. You do this dot/dot, and it will test everything. But when you have the problems here with the benchmark, you do everything, and you get to this last stage here with the benchmark. This step here. I'll show you here. Then please just do like this, dash race. This is, if you do this tip here, a lot of the times it will tell you where you have a race condition, and this means you know where it's probable that you can have a deadlock. It's not perfect, of course, but it can really help you to find this deadlocks issues that you might have. So remember this race flag. Yes, I don't have a great example for this now, but yeah, do if I can do it here. No, but yeah, remember this race flag. Okay. Anything else about lab 4? Or yeah. Yeah, you can also see this images here. Oh, I think that's it. What I wanted to say about lab 4. I don't think that we require you to use either TCP or UDP. So I think you're free to choose this yourself if you want to use UDP instead. But yeah, actually, I saw one year one student used the UDP, and then he added like acknowledgement on the UDP. And yeah, I just want to say that this is not necessary if you if you have some like you want to get some assurance that your message was received. You don't have to implement acknowledgement on top of UDP. You can just use TCP. Yeah, so of course you are free to try to make the lab more advanced or more cool, but yeah, we will allow you to do the most simple way. If you for example require TCP, then just use it directly instead of implementing it yourself. Can be time consuming. Yeah, okay. Is there any questions about lab 4? The deadline, it's see what I put. March 15. So you have 1 month on this lab or so. I think it's 15 today. Yeah. Yeah, I think if you can understand this lab and do a good job, then these two next one, it will be easy for you. Because on the lab 5, you need to implement like a use case of this, and what we call a banking client. Like you will use Paxos to run a bank, and also create some web interface to what's it called, web net bank, or like a web page to your internet banking. And yeah, for lab 6 you will choose if you want to try to do some reconfiguration for Paxos, or if you want to have a batching or pipelining optimization to make it more high performance. So both of these labs, they assume that you did a good job on lab 4. Yeah. Okay. So is there any questions about lab 4? Any tips that you need? Because some students came to me and asked me to give you an introduction to lab 4 about what you should do. And hopefully I did that, at least that you have some tips. And yeah. No questions for anyone. That's great. Okay, another thing is that I got some message from I'm not sure who sent it. Tom William, I think, regarding lead dialogue, and I think that you should have received this. I'll try to. Yeah. This semester we have sent a short survey to the students for each course. The results of the surveys will make the basis for the dialogue you are to conduct. Note that even though we have received a good number of answers from the students, there are courses where there was no feedback. In those cases, conduct an early dialogue as before. Yeah, I think that you will have received this already, or it will be, because it said that this early dialogue should be from 15th February to 26th. And yeah, I guess you will get a Google sheet or Google form where you will write your comments about the course or whatever you you like, and there was and then I also got the message that Tor Håkon Andersen was chosen as tillitsvalgt, and yes, this in English it's class representative, and I guess the idea is that if you have some comments, you can go to him, and he can relay your comments about the course if you have any feedback, for example. Or you can come directly also if you like. Is it correct, Tor Håkon, that you were chosen as if you are with us, as the class representative? Because you haven't heard anything about it. Okay. Yeah. For me, it's fine, and it's great. I'm not sure how you if you usually there is an election process or how it's usually works. But for me, this is just great. But maybe someone else has a comment that they have some objection regarding this. So we can, for example, choose this on Thursday finally, and if someone has an objection that Tor Håkon should be the class representative, they can let me know within Thursday, and if there are no objection, then Tor Håkon can be the man if he wants to. Yes, that was that. So yeah, other than that, I didn't plan anything for today because I thought that you would have a lot of questions. Oh, it's still missing. Okay, let me. Are you? Is it? Did you get access on the student web, or is it? Is it just Canvas? No, I don't think you are the only one either, because now I used to have 40 students in the course, and now it's reduced to 5 on Canvas. So I don't think that so many of you left. But but do you have access in the student web, or is it working on student web? Like, are you assigned? Okay, you could find on student web. And are you signed up for the evaluation on student web? That's the main thing, that you need to be signed up for the evaluation, like so that you will get a grade. Okay, so it was there. All right. Yeah. I think talk on that's like the issues are somehow connected. That if you're not signed up to classes, then you don't have access to Canvas. But yeah, I sent a, I guess I sent an email around 2 weeks ago. And I'm not sure why. And then they said, you know, everything is normal. It's working how it should be. But now we already waited a long time. So I will send another one that, yeah, make some drama that you need Canvas so much. Okay, I will do that after this. But really, we don't have a single questions about Lab 4. Everything is really, now it's 100% clear. Actually, yeah. Well, if you just if you need help to get started, ask the TAs or ask me. But try to yeah, if you let us work on it and then ask questions, it would be great. Yeah, I agree. Yeah, just we will, as I said, try to publish this lab very soon in the next couple of days, and then try to get started on it as soon as possible. And yeah, ask questions to me or the TAs or other students, and yeah, try to finish this. It's a very good tip for you all. And if you do a good job on this, then Lab 5 and Lab 6 will be very. I don't want to use easy, but it will be very manageable for you. Yeah. So okay, if there is nothing else, then I will try to publish these labs, and we will meet on Thursday. I just want to make sure. Do we have a lecture planned for Thursday? On the 18th, yes, it will be chapter 6. We will just move this consensus variance to 1 week. Yeah. Okay, you are in the student web. Okay. Well, you know, the one of the questions that you will have in the thing I talked about earlier with the course evaluation, I think one question is that that you have like been given access to Canvas. So if everyone lost access, it's not so great. Yeah, okay, I will not keep you for just for too long. So let's meet on Thursday, and that's it. That's it for today. So see you on Thursday.